Hello. Yes. Very good, very good. So today I want to keep trying to fix the infinite loop in the new physics algorithm thing. I didn't do a lot of brainstorming to try to think about it. Nope. Fix a crash in the regex engine. I hope that's what keeps happening to me. Okay. Ah, I would very much like to merge the pull requests, but depends on this other thing. Hmm. Okay, well, let's open it up. Okay, there's MD4. How could this be cleaner? Hmm. This is a huge number. Massive. I'm gonna switch over to YouTube Music. Uh, Hopefully it gets like fruitier arrowy, cause this is kind of like music. I mean, this is annoying that you have to implement 4 traits just to be able to. It's not too bad though. Mm. So it comes in here. And passes all the tests. So all of these triangles are above the origin. And then it keeps going and going. And it encounters some kind of situation that leads to imminent doom. Let's. Oh, really? That controls the volume? Let me draw it. Is there keyboards or mice that are good for bhop, specifically strafing? All preference. Really the only thing would be like high DPI or like literal cheats like nulls built into the keyboard. I mean, probably mechanical switches are better than membrane, but that's just blanket always true for any game. Knowing the actuation point is very good. High DPI, really. So just any gaming mouse that's accurate is good. I don't think there's like a particular bhop shaped mouse type thing. Okay, so I'm gonna draw. I'm using this one. Just G Pro Superlight Wireless. G Pro Wireless Superlight, recommended by my my friend. Use the same one, yeah. Very very highly recommended mouse. Personally, I prefer the Razer mouse shape that has more volume, and like I don't care super hard about the mouse being super light. I think it's just because my hands are a bit bigger. I think this one's hurt my wrist over time because of that. But Razer doesn't make good mice anymore, so oh well. Turn the music down. Really? Oh, is my microphone turned down? The music is like way down. It's my microphone. That's the problem. Why? How? Oh no, this is something else. What? Is it okay? Like the microphone goes to full volume. What's wrong with it, man? Uh. Okay. Ow! I just bit my cheek. God damn. For nothing. I'm like not even chewing anything. Alright, here's a shape. It's a shape. That's a shape. Ah, it's a shape. Okay. Then we have the inner shape. U u e a. Heard you wanted to ban nulls. Is that true? I consider it cheating. It's not like my agenda or something. Like I don't know. I consider it cheating. Is pretty much the beginning and end of it. I like to give the moderators leeway to enforce what they think, what they want to enforce, as long as they all agree on what to do, and it's not totally insane. I'm sure that's happened before. Nice. Total failure. Little chocolatey bits. Oh, it just sucked on my finger. Oh my god. Finger magnet. How? I don't understand how the music can be loud. I'll just turn down a little bit. Okay. This is what's up. This is what's going on. This is the algorithm. This is the thing that happens. Okay. Well, okay, so let's do the algorithm. Okay, so we need a test point. So we're trying to find the closest point to that. So let me. Okay, so some other algorithm has run, and it found a volume that encloses this point. That's made up of points on the surface of our black mesh here, the outline, and it's given us a tetrahedron. Well, in 2D, it's a triangle that's made up of surface points that encloses the point. And our goal is to find the surface that is closest to the test point. So it's like, which face of the mesh is the point closest to, and the point is on the inside, and this is the starting configuration. We know for a fact that the point is inside the mesh. We know for a fact that we're starting with a triangle, with a tetrahedron that contains the point. Okay, so then the algorithm is, of our triangle faces, so this is a face, which one is the closest to the point? Cool, it's this one. Okay, so the algorithm says, find the point on the surface of the mesh that's the farthest in the normal direction. Oh my god, I'm bad at drawing arrows. That way. The point that's the farthest that way. So that should be this point right here. And what you do is you break the triangle and then make three new triangles in 3D, or two edges in 2D. So like, we'll just do 2D. So I've done one step of the algorithm. So that line was the closest to the point, but it turned out it wasn't on the surface of the mesh. We're trying to find the closest face on the surface of the mesh. How do we get to drum and bass? Like, it was supposed to be fruit or arrow. Whatever. Okay. So then what's the next closest face? Well, let's say it's this one. Crap. It's like there or something. Okay. So our triangle went like this. So then, jeez. So This face is the closest, so break it open and draw 3 new triangles. Cool. So the face that was the closest is now closer to the surface of the mesh. And in this case, it's exactly on the surface. But now there's a different closest face. It's this one. So we need to push this in this direction. So then we draw it like this. So we're pushing this way. So that becomes this. And then the next closest one, it could be either one of these. I believe it's this one. And we try to push it this way. But it's already on the surface everywhere. And there are no... So when we grab a point, the farthest point in that direction, it's already at the same level. And that's our exit condition for the algorithm. And we say, we found the closest face to this point. It's right here. It's that one. That describes the escape algorithm within the minimum difference algorithm. You start with a little triangle and you push out the sides until you can't push it anymore, and then you found the closest face to your test point. And what's happening is one of the faces, after being pushed away, somehow is below the point. None of them should be below the point. So all of the faces are oriented. They know their orientation. So it's like directed. It knows that the edge goes from here to there. It doesn't go the other way. And it knows that it needs to move this way, and it knows not to move that way. It's the face is oriented. It has a top and a bottom. So somehow some face thinks that it's on the wrong side. Like they're all supposed to move away by construction rather than just detecting which side the point is on. So like there's two ways you could do it, right? You could like, oh, the point is on that side. I should move this way then. No, it's not like that. The face is oriented and it always moves in one direction. So I can't imagine any case where this could happen. And it bothers me quite a bit because it's happening. If we build this, strafe, cargo, build. Oh. For real. Okay, it built, we run. Whoa. Oh. Goddamn. A lot of numbers, indeed. So these are hexadecimal numbers. So the digits are from 0 to 15. It's base 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. And it stops at F. F is the largest digit. So this is a decimal point. This is 0.12. Learned this in IT. Stressing to learn. Ten fingies. If we had 16 fingies, the world would be easier. Computers would be easier, rather. So less. Say less. Wait a minute. D. For diff D. Interesting that diff is very close. Oh, it's exactly the same. What? What? Hmm. Zero, zero, zero. Less than or equal to. Oh, 440. Okay. 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 So it is a algorithmic continuation. I'm so worried that the algorithm is like starting badly, that like the initial tetrahedron, the point is outside the tetrahedron, and that's like it's one of the assumptions that the algorithm makes that makes it so simple. But it's never been the case. It's always been there. Whoa. What about the simplex? Uh, Shrimplex. Golly. Simplex on escape. Bup. I'm I'm curious. I'm gonna check if the simplex is oriented incorrectly ever. It could very well never be oriented incorrectly, or always. Inverting simplex. It's true. Okay. How do I debug this? Um, yeah, I didn't really think about this while I was not streaming. Gosh, this is such a nice algorithm. It makes me think that there's probably a better one though. Like if because like if you have a mesh that's freaking huge, but you don't ever really have a mesh that's freaking huge because they're convex meshes. And like as you add more faces to a convex mesh, it just approaches a sphere. So it's kind of pointless to add faces to a convex mesh. So you don't need the complicated machinery to like spatially index it or like make it speedier and stuff. You can just deal with O of n because it's n is always pretty small. Like I basically control the boundary, the like source of meshes. If, if you make a bhop map with a sphere that has a million faces, it's gonna lag. Duh. So don't do that. If the algorithm is so simple, how come there can be bug? Help. It's gotta be like a messed up triangle. Where like two vertices are the same, but then the cross product would be 0, and then the distance would be 0, and like what? And it's not. That's not what happens. How? 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 Distance is negative. Okay, I'm thinking about like multiple parallel faces on the same side of the convex shape. So that'd be like if this part was a straight line from here to here, but it's two separate faces, and then you go like, "Oh, I'm building my triangle here. Oh, delete this face," and then you go, "Oh wow, oh, it's between here and here and here and here and here. Somehow delete the other. Something somehow does that. Okay, I actually know how to do that, but okay, I'm gonna make it real because it bothers me. Okay, me when the face is. Oh, jeez. Okay, if this is your starting triangle, then you delete this face. It goes like, oh, what's the best one in that direction? And it's like here for some reason. Imagine they're parallel. What? What? And now you're expanded like that. It just still works, man. Is this because I sent a circle? No, this is a algorithm. I'm trying to think of ways that the algorithm can fail because I observe it failing. What if the normal is negative? It's just straight up backwards. Okay, so what is the thingy printing here? Sort distance. Me is the sort distance. Triangle, sort distance, negative. So the sort distance is a negative number, but that's, I put a minus sign there. So the distance divided by the normal. Oh, it's squared. Okay, well, what about this one? These, we print those as well. That's right here. So the distance is a positive number. I don't get it. I don't get it. These are positive numbers. And then it generates a negative number out of nowhere. Why? This is very. Oh, it's Hardcastle. Okay. It all makes sense then. Very nice music. I need more Hardcastle. Why did they create negative numbers? I don't know what you're talking about. So there's either a bug like right here or a bug like here. Like maybe it's negative norm. But that's what I was saying. I was saying like if the point faces away. So all of the numbers are positive. Farthest direction. Well, let's just try it. Just try it. Just. Run the track. Oh! It stopped crashing. What? Triangles 4. Oh. Okay. Okay, it's just saying, "Oh yeah, dude, your tetrahedron is good, dude. Yeah, dude, that's good. That's good. There's nothing closer, dude." And it's wrong. So it like makes a negative triangle. Well, no, it picks a point that's below. Okay. Okay, so it's just the algorithm is just not working now instead of not working and crashing. uh, the algorithm is now simply implemented wrongly instead of something mysterious happening that leads to a crash. Actually, well, the crash isn't mysterious. All I'm doing is checking, is asserting that the number is not negative because I expect it to be positive. Always assert your expectations. Oh, I saw it. It inverted the simplex. Is it sometimes inverting the simplex? It is sometimes inverting the simplex. Huh. Sometimes I invert the simplex. Wait. It doesn't make sense. This is where like unit testing would be goated, and if I just like actually tested the freaking algorithm with like specifics, and I was like, on this mesh, what face is the closest face when you do like this? And it does it, and then I get like a result. And I guarantee that the algorithm works. Instead of trying to like integrate everything from the get-go. But I never do. I never do that. I always assume that I write perfect code and just God, it feels amazing to play this. 1,500 FPS is no joke. It does not feel amazing to hit those bumps, I must say. Oh, wait. I just can't think of how the algorithm could possibly fail. How can I debug it when I can't imagine it failing? Like my mental model conflicts with the reality I'm seeing. Yeah, I guess the main failing here is I only have the like numbers. I don't have a visualization. If I had like a little visualization on this, if I could like stop the game every single time it reached the point where the algorithm's running, and then like mash a key to like step the algorithm, that would be great. Ugh. But like when you have your own engine that you made from scratch, that is just a colossal scope to even consider. Is that a freaking you can go inside the wall type thing? What is that? Okay. No. Damn. Just slip through the wall. Just kind of slip through the ground, slip through the wall. Just whoop. Did you not just literally explain what a debugger does? Well, debugger's still numbers. I was talking about a visualization. Like, I can get this very similar information from just printing. Which I am already doing. Ah. No, dude. Go in the wishing well. It's just a normal well. Sorry for misleading you like that. Wishing well just sounds better. Okay, so if visualizing the algorithm is not an option because it would take like a week to write a visualizer, then what can I do? What I need is a failure case. The problem is that maybe it's not so rare. If I can get this working, I think I can fix zero-time collisions for good, which would fill that's the biggest It's the most common fall through the ground case is a 0-time collision. So like I'm right here, and let's say there's 2 parts here, and I like walk from the left part onto the right part. I fall off of one of them, and I have to fall onto the other one in 0 seconds. I wasn't touching it before, but I am adjacent to it, and the current algorithm cannot say yes, you collided with it when it would take 0 seconds. It goes down a different code path, and this escape algorithm is what existed in that code path in the source code that I ported it from. So this is the escape code path. So like you have these 2 meshes, and then it finds it found a common region shared by both meshes, which means that they are intersecting. And that's what the escape condition is. And then it's called escape because it's trying to escape from the mesh. You have a tetrahedron. It's a tetrahedron. It's a simplex, 4 simplex, 4 vertices, and that is the shared volume between the 2 meshes. And it's trying to find the closest point on the surface of the mesh to the origin, but it's the origin because the meshes are shifted by the test point, like this. They're shifted. Wait a second. Can I just blast it together? Hold up. I wouldn't need to do this. Oh, this is on the go away. I mean, you have to do it anyways, though. It doesn't matter. Just hold. Okay. So I was previously doing nothing in this case. Intersection is guaranteed at this point. And if you're testing if a mesh contains a point, well, easy. It contains the point. You're done. You don't need to like find what's the closest point or something. But if you're trying to find the closest face edge or vertex, so this is like, okay, why is it like this? Is intersecting, huh? I don't really understand. Found enough information to compute the exact closest point. I don't understand. This should probably return something kind of like this. No, I guess it would be this. Huh. Because like it doesn't need to do all this work if it is intersecting. And you don't care about the exact. But if you do care, well, now it's just destroyed the information. Okay, that's not what I'm trying to figure out. Which way is forwards? It's this way. Go up. Oops. Oops. Beep boop. Oh, I suck. Yep. Ah. Uh-oh. I don't make this. Oh, I made it. Wait a second. How do you... Oh! Ah! Ah! I have never kept the speed out of the... to the fullest extent. Okay. I don't really know how to debug it. Why is it doing that? Is it close? Can I just... No, it's not really close. It just... Like... Okay. Okay, stop playing the game. Okay, so... So I'm printing all the triangles, sort distance, which I don't need to do. Oh, if I could just see it. Okay, what if I use Mathematica to see it? Oh god, I need freaking hex. I can just print it good or something. Okay. Okay, let's go for Mathematica hex or Mathematica hex. Mathematica like convex mesh something. Okay, how do I do this? Triangle? Let's see. Oh. Okay, so every time it discovers a new point on the surface of the mesh, print it. Fart vert. No. Oh, okay, well this is always. Ah. Vert plus point. This might work. I need to think it though. Good. Okay. I need the exit condition. The like, oh no, we're dead. This one. Oh no. It's broken. And then I need the vertex positions. Okay, so these ones are the Okay. simplex. Okay. Okay. I need to say hi. This is the beginning. Begin. Expand. And then I need to say, I'll just like print them, and the first four are the ones. V. You good? No. Oh, that's right. It has to be right. Mesh dot friggity freak. Vert. V. Deref. Okay. Okay. Right. Right. And then aha. 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 Whatever. We'll just go like this. And then this one, next pause. Go for it, bud. Okay. There are the vertex positions. We got them. And then the one that kills it, we actually don't know which one it is. We'll see if it matters. Okay. Print. Please. Please. I hope this is cool. Please be cool. Alright. Go die. Good job. Okay, so now these are our points. Whoa, whoa, whoa. Okay. Okay. So now I need to go like, and then I need to go like, and then we put it into Mathematica. No, Mathematica. Oh my god, I love having no responsibilities. Okay, so then go like that. That is a list of points. Convex hull. Mesh. Oh, why is it so slow? Bruh. Ain't no way. Can't you just be not like this? As slow as well. Now we have another problem. Mathematical lag. Render lag. Well, performance. Yeah, great. GPU acceleration. Nice. Yeah. Okay, what okay, what if I go like this? I actually don't know if it's okay, that looks exactly the same. God, really? I can't just use this software. Oh my god, it's there. Okay. Okay, problem solved. Okay. Well, there's our convex hull mesh. This is all of the point. So the mesh is like more. There's more stuff in the mesh than this, but these are all the points that were visited. Oh my goodness. Okay, so first 4 points. Let's do show convex hull mesh. And then how do you do like good? How do you like transparent opacity? Okay. Oh, and then we go like okay, and then we go like oh, come on. Times? Oh god. We good? Oh, well, that's cool. Okay, so we got the we got the tetrahedron in there. There it is. Why don't we do both of them? Oh, as transparent. It's kind of hard to see. 0.1. Okay, and then point, I guess. Wait a second. Is that point slightly different? Be right back. Alizia, distant ocean. Okay, this is to be expected. So notice how the point is right on the edge of the tetrahedron there. That's because the objects are colliding. Exactly. Wait. Is that true? It just started. Does it have to be like that? Okay, why don't I print it more accurate? Gabagoo. So let's try more accurate. Okay. More accurate print here. And let's see if it's the exact same point. Ooh, I'm running this in the terminal. Okay, go. And die. Okay. Why did it just do the exact same thing? Oh, it wasn't finished building. Okay. A75 8F26 BC1. So it is the exact same point. Non is negative. Does not go away 0. Whoa. Okay, so let's do if my guy is negative. Print it, I guess. Um, go for it. I don't see how it couldn't like become degenerate. Like if two of the vertices of your triangle are the same, the normal is 0, and then the distance is 0, and then it's still not negative. I just don't understand how it can fail like this. Okay, so we got 9E, 6-1. We got 12, the first point. And then we got the last point. The last point. Really? Really? Why are these all like slightly different? Is this rotated? What the hell? There you go. Good job. Linux killed Mathematica. Fun stuff. I believe Mathematica had a memory leak, and that's why it was lagging. My whole computer locked up for a second, and the stream ended, which is fun. Let's enable swap. Maybe I should just do that at boot. It's got me so many times. Why is Mathematica memory leaking? Is it like the GPU driver or something? I thought I had a path to success, and now the software doesn't work. Well, the interesting part to me is that there is no degenerate triangle. So, like, it doesn't have three vertices that are. Do I still have the negative number here? Norm. That's gonna be a problem. I'm gonna take it away from here because it's very bad. There we go. Oof. So I don't have the negative norm. I'm really happy that Pipewire didn't crash. That's very nice because that means I can still stream. Hello, music, video pause, freaking YouTube. Has even been like, dude, oh my god, YouTube sucks. I hate using YouTube for music. I'll go with that. Okay, so is it like really negative or is it like slightly negative? I don't know. Okay, well that doesn't actually say anything. Freaking let's do the big one. Give me the actual distance. Wait, what? Oh, ratio. Okay. Hello? 8320. Is that too big? Crikey. Whatever. Okay. Should be good enough. Go again. Give me the actual real distance. Distance. Four units. That's huge. I was expecting like 0.001 or something. Okay. Wait. Oh. Oh, that's the absolute distance. Okay. 4 units. You know, I need to print the. I need to. My God, why did Mathematica memory leak? That is so irritating. What's like an open source one? Yeah, algebra. Galgebra. What's it? I don't know. Maple. Not open source. Calgebra. What the hell is that? GeoGebra. That's right. That's the one. Number 13. Number 13. Wow, it's self-sufficient, eh? Alright, well, good luck. Can you just, like, do it? 3D. Okay. I mean, this would be sufficient. This is using X-Whaling, isn't it? Ugh. Can we just not have a memory leak when I'm trying to do stuff? Oh. Okay, looks fine. Let's keep track of the old memory usage. Okay, hopefully it frickin' behaves. Alright, here's our frickin' points. Graphics, 3D. Opacity. .5. Frickin' convex Hall mesh. Frickin' some points. First 4 points. Okay, opacity. We're not filling up on RAM, are we? Okay. Convex Hall mesh. More points. And point. 0, 0, 0. Okay. So that was the plot before. And now. We need a triangle. So I'm printing in hex. Mathematica doesn't do hex. Let's stop printing in hex. Okay, go for it. Irritating software. I've never had that problem with Mathematica. This is the first time. Okay, run. Show me the numbers. There's the numbers. Give me the numbers. Yoink. Okay. Eh, eh, eh. Yoink. Triangle. Show me the money. Oh. Let's keep tabs on memory. Okay, is it VRAM? Oh. Is it just like leaking? Are we gonna see the yellow line go up as I like look around? Who knows? Okay, so it looks like the triangle is out back here. We're not leaking memory, right? Okay, wow. Oh, okay, it's doing the bad. It's doing the bad. Don't do the bad. Okay, give me that. Give me that. No, just this. All right. This thing is gonna kill my computer again. Okay, so the triangle is right there. That's confusing. That's very, very confusing. I'm quite confused. But it's a nice picture. I don't understand how it could possibly fail. It just in my mind is totally bulletproof. I'm like waiting for something to just jump out at me and go like, "Oh, obviously it could fail in this way. Obviously, you dumbass." Length squared divide rep 128 square root infinity. Like it does it just like magically orient wrong? V0 like this is a correctly oriented triangle. We are introducing a new point above it and it just dies. V0, V1, new point. The new point is supposed to be in there, but if it's like over there, the only way that can happen, it's a convex hull. The only way that can happen is if it's not a convex hull. But it is. Like, cycling these points shouldn't matter. V0, V1, V2. How can the diagram look so good? Like, it's such a tiny algorithm. There's like 15 lines of substance here. Like, if I get rid of all the crap, it's widowy. A tiny bugger. Ah. Is it backwards? Make it not backwards. Ah. Ah, we have 4 triangles. Oh, what's the closest triangle? Oh, which way should the triangle go? Oh, what's the point farthest in that direction? Is it above the triangle? No? You're done. Oh, if it's not above the triangle, make 3 new triangles. Loop. That's it. There's nothing else. All the guarantees are built in. I am curious about this thingy extend. Rebuild on drop. Cool. Oh, Vec. Oh, what the hell? Damn, son. It's just a freaking Vec. That's Nito Burrito. Mutt. Ord. Ooh. At. Empirically. Cool. How does it get turned inside out? V0, V1. I have the total order here. So, like, this is... I guess I don't know exactly which dinguses were changed. No, don't save. Wow, wouldn't it be nice if there was a program I could use to visualize a convex hull? What? Like Mathematica? Whoa, that's crazy. Computer crashes. Oh my god, man. I just want to look at the convex hull. Convex hull. Like, oh, dude. I don't want to learn an entire new software just because Mathematica has a memory leak. Sage math. Right. Okay, well, this sucker didn't work. Failed. Okay. Not good enough. Sage math. Oh boy. Why is there 1,000? Message. Okay, I see. Oh, it was just open source. Yeah. Okay. Okay, so it was in the thingy. What is this skibicle? ECL skibicle. Why is there a choice? Skibicle. Okay. Number 2. Oh. 3JS, JavaScript, and Python. Okay. What am I gonna do? Like this is what they chose to write it in, so this is what I have to do. Oh my god, bro. Sage. Math. Okay. Where's the GUI? Swap top. How do you do it? Hell. Graphics. Produce. So you don't have like a notebook thing? Real? Like, this looks good. Is this... Book a demo. Can I just like do this? That was slow. Sage. How do you spawn the UI? Help. Click. What is that? I'm guessing this is not what I want. Required by... How do you see things? How about that? Yeah, pricing. Can I just like do it? Yeah. Why is it so hard? Okay, well let's look at this. Alternative 3 plot engine. What's the non-alternative? Rubik's Cube algorithms? Like, is any... Meat Axe. Interesting name. So I installed this thing, and in the tutorial it says, click on this from the Sage Notebook. How do I get to the Sage Notebook? How to open a Sage Notebook. N. Holy smokes. Okay. Jesus Christ. Oh, nice one. Nice one. Nice one. No module named notebook. Right. You think that'll work? So give it a good shot. To access the server, open this file in a browser. Why do they give you a choice? Oh, did it already do it? Okay. Something is happening. Cool. Okay, that was not simple. Yeah, just install this random dependency that's not listed anywhere. Easy. And then just type this random command that's not listed anywhere. Easy. Environment variables. Okay. Oh yeah, dude. Yeah, just do it, man. So easy, dude. Sheesh. Okay, well, it's running. Plot. How plot? Please plot. Rella? Documentation. Maybe I should have looked for this first, huh? This is tutorial. Why don't we go... Okay. Hull? Any sort of hull? No, this whole thing was a waste of time. Okay. Okay. Bye. Yes. Bye. Alright. Remove it. Mm. Bye. 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 Okay. Purged from system. Okay, that was a waste of time. I would totally do a Mathematica thing online. Gosh. Well, that was a giant waste of time. Let's see if I can find. Is it the bot cruncher? What had the SN fix mouse? Did I just lie? Great. I love it when YouTube just stops. It's the best. This is just not the type of music I'm trying to listen to. It's just something else. I just don't like it. This is closer. I don't like the like lagging sound that those songs have. What am I looking at here? Can you even set the fly speed? No. Man, I could have made progress, and Mathematica just memory leaked or something, and now I can't make progress anymore because nothing I know works. All I need to do is see. But okay, so I did see the convex hull, and I did see the triangle. The triangle isn't some degenerate triangle. It's just a normal triangle on the surface that's freaking backwards or something. I would love to see an animation, and I could actually do that with Mathematica. But it freaking wants to kill and murder my computer. Can I like use C groups or something and like limit them? It just like, oh my god. Oh my god, do I just reboot and then use Windows in a virtual machine, of course? Never touch Windows on bare metal hardware. Okay. Oh. And then I have to deal with the freaking other software that crashes. Underscore, underscore. I wonder if that's already in my terminal. Yep, there it is. Oh. I can't believe I want to reboot to use Mathematica on Windows. Oh, I don't even have it installed. I think. I wonder if the new version is fixed. It very well may be. I tried to install it on my laptop and it died. So great. Uh, I'm just really disappointed in the software that I tried to use. Now what? So I did successfully visualize it. I assume that the triangle is just inverted somehow. How the hell would that happen? So this is potentially all the data I need. Like, oh, what would be super nice is if like it adds one point at a time. It goes like triangle that way, adds a point. Triangle that way, adds a point. Triangle that way, adds a point. And you can like watch the algorithm progress in a visualization. That would be beautiful instead of having these stupid numbers on my screen. Then I could see it and go, oh, that's wrong. It's not supposed to do that. I know what the algorithm is supposed to do. Instead of like, okay, 198F269BC1. Oh, yeah, so I see it in my head. There's no way. My visualization tooling is lacking. So, okay, well, something I'm noticing here is that these numbers are slightly different, which is very strange. I would think, like, what the hell music is this? This is not Fruitiger Arrow, my guy. It's very close, and that like leads to me to believe that we're like seeing some sort of degenerate triangles. But then like when I go to look at it, none of them look degenerate. Like the entire math pipeline front to back is exact. There's no rounding. Like this is a freaking ratio of two massive numbers. There's no way it can fail to get the order correct. And then like farthest vert, it's a dot product, man. It just loops over everything and finds the one with the biggest dot product. Well, it's nice to have the entire algorithm on screen at once. Why is this highlighted? Oh. What do you call it when the vertices are in the wrong order? Like you could say chirality, but that's more like a physics term. Winding order. That's good. V0, V1, V2. So like it's literally just taking the vertices and like changing like V2, V0 is in the correct order. V2, V0. It's like raising three triangles up to the point that just can't be wrong. There's so little going on in this algorithm, especially compared to the code that surrounds it. And it's just boggling my mind that it fails. I got a nice visualization, but it's just it really wants to crash my computer, and I really don't want it to crash my computer. I'm so stuck. It would be really nice if there's like a circle with like arrows on it drawn on the face of the triangle that showed the winding order. That'd be wonderful. I just don't understand how it could go wrong. So simple. Oh, I wonder if it's already okay. I see. Um, what about this? Is there another way to represent this? Because it's cross dot dot. It'd be nice if there was a way to do it with smaller numbers. Because we have 4 multiplications here. And then 6 here, right? It's like 80, 48, 6. So 256 is 4 times 64. And then this is 6 times 8. Be nice to get those numbers down. Give it another shot, I guess. Uh, hmm. Oops. Frick, I've got no idea. Uh, it's got to be that. So the distance is -4. It All right, here's our freaking points. Number 4, here's our convex hull mesh. Number 4, select. Oh, it's semicolons, doesn't it? N. Table. Hello. Table. N from 4 to length. Number 4. And then animate. Go. No. Oh, list. Hey. Uh-oh. Dang. I've got no idea what's going on. Where's the last point? Rah. Oh, I know what to do. Stop. Okay, so it legitimately did nothing? Oh, I forgot to remove the extra point. Okay, it legitimately did nothing. Okay. So the thing is, when it picks the same point, what should happen is it finds out that the triangle distance. Why is this so freaking loud? God, it's tiny volume, but it's blasting. It finds out that the new point is not above the current triangle, and it exits. That's just. Oh wait, 16. Oh. 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 Okay, so this is the last one. Second, So this one is right here. That's when that one is added. Uh. So is right there. So So then what axis is this? They're not freaking labeled. Graphics 3D. How do you label the axes? Yeah. It didn't work. We okay. Is that the problem? How could it possibly? Uh, well, yeah. We're not gonna run out of. Yeah, I don't know. Okay. Um. What is the norm 0? Okay, what happens when the norm is 0? The dist is 0. Uh, and it puts the triangle last on the little heapy. All right. Let me see that later. Okay, so let's print the norm. Maybe it sucks for whatever reason. Farthest vert. So it okay, well yeah, no, that would do it. Adding it's adding a vertex that's already inside of the triangle list of the like working mesh, which is the triangle list, which is supposed to be impossible. You're not That's not supposed to be able to happen. What? Normal 0. Okay, so none of these are 0. Okay, well then why is that freaking different? It should be exactly the same. DF. Oh, it is exactly the same. Wait, no, it's not. This is the normal, and then this is what it picked. And this is the normal. It's literally the same thing. The same direction. Is the negative 0? Okay, it might be slightly different actually. I guess I could print it Scoobert. Okay, normies. So this one. Okay, so it is slightly different. So it does. Oh wow, it's like different everywhere. What the hell? Did I just find like a magic? Like, there's no way. It just cannot happen. There's norm and negative norm. It cannot return a point that's not on the surface of the convex hull, which is the same as the surface of the mesh for a convex mesh, which it is. It is a convex mesh. Huh? Huh? Is this the source of all my troubles? How the hell is farthest vert the weak link? Is there some sort of amazing bug happening? Vert, mesh 0, mesh 1. Look at this. Farthest vert, max, dot. It just finds the one with the biggest dot product. That's it. I don't need to do this. Like, it just regardless, there, it's it's not an issue. What about this one? Transform 0.3. Really? Is this just like because I listened to this song before? It must be. YouTube is irritating. I'm not just trying to like relive my past memories. I'm trying to like find new music. But okay, whatever. I just don't have the effort for it. Is this verts? Data verts iter. Data verts iter. Topology verts iter. Like, this is a transformed mesh. So verts, I'm just whipping through the data verts. Transformed mesh data verts. Data verts? View topologies. Can't the mesh topology be a subset of the mesh data? And it never is, but it can be. So that would make this wrong. And it would make this right, which is the one I'm depending on. Transform point 3. Like, it just doesn't matter if there's rounding going on. Enumerate by max by key. Just find the biggest dot product. It just does not matter. It will always give you a point on the surface of the Minkowski sum of the two meshes. It just does not matter. There's just no world in which it's giving you a point inside the mesh, which it appears that it's doing here. What the hell? Is there like an indexing difference? Like, I've looked at this code before. Submesh vert ID. Why is topology verts data verts? What the hell do I mean by this happens to be well defined? 3 months ago. Oh. Mesh vert ID. Topology verts. Like, that's dot 0 as u32. That's the definition of submesh vert ID. Topology verts. Did we'll see. It just looks like this function is returning a bad result, which should be impossible. Oddling. Another nice song that I've already heard. View data verts. That just looks wrong. 2 years ago. Shouldn't this be topology verts It's a physics mesh view. And then I could like use this here. Transform 0.3. Verts max. What are we? Oh, wait. Topology verts. Submesh. Transformed mesh is a submesh. Physics mesh view is a submesh. Transformed mesh is a transformed physics mesh. I suppose I could actually make it generic. Mesh transform. Why is it a reference to the mesh transform? I guess. So I think that this just so happens to work because there's no submeshes in any maps ever. For now, there's one submesh. Every mesh has one submesh, and it's the entire mesh. Submeshes being a convex subset of the complete mesh. So this just happens to be the same as this. So, the only way I can see is if this is returning the wrong vertex. What the hell does this mean? Virtual vertices? I misspelled it too. Is that for like convex submeshes? Like if you imagine you have a donut and it's like low poly donut and there's like 8 sections, so it's kind of like an octagon donut. So you have 8 submeshes. Another song I have already heard. Another good song I've already heard, but like, dude, new music. The point of this playlist, or what I was hoping for from this playlist, I guess. YouTube is just hoping to keep me on the platform, whatever the algorithm wants. The engine is smooth. We'll be sure to use it. Interesting comment. Topology verts. This is. Oh, it doesn't. Topology verts. Oh, yeah. Oh, this is one of those things where, like, if it's wrong, then everything is wrong. And how does it work as well as it does if this is wrong? Inverse. That can't be good. Yeah, no, it can't be good. It's too much multiplication. Oh, I need to eat the cheese. I'm just like sitting here trying to think of how it could be wrong. What I need to be doing is like testing. Testing what is wrong. Yeah. The convex hull visualization is pretty cool. This is cool. You gotta admit this is cool. Adding points to the convex hull. Hell yeah. Well, wait a second. It doesn't. Well, no, that does work. That does work. God, it's cool. Okay, why don't I blast this point onto here? Frigging, go for it. Go nuts. Point. So, oh, interesting. What the hell? This is the problematic point, right? 12 12 4 19. It's 16. That is 16. 16. No, this is like 18. Wait, what? $17.9. How do we get here? Okay, well, it's not inside. Okay, so like either that one or that one is 16. So 4. Okay, what if I just say 7? Where is it? Okay, so now it's outside. Which 16? Are we not seeing that anymore? This is 16. Okay, it's the 10. Crikey. Okay, 16, obviously. Dumbass. Okay. So 362EAB. So this is larger than this. 360, which would explain why it was picked for this direction, and then a different point was picked for this slightly different direction. So we have a very slight convexity, which is, it should be totally fine. How does that point end up? Okay, where's the freaking triangle? Okay, put the stupid point on there. Crikey. Okay. Point. Okay, there it is. How do we end up with this triangle? Wait. Crikey. Okay. Okay. Another point. Another one. What's the next one? It's a duplicate of this one. Another one. What? Oh, there it is. Okay. So this is the new point that was already a part of the mesh. Triangle. Who is the triangle? Ugh. Normals look good. Positions look good. Everything looks good. It just blows up for no reason. All right. God. I need to print this triangle in this function when this goes wrong. Alright, I know what to do. Just friggin' slap some crap option, some print, return, none. There you go. Okay. Yeah. Let me go here and go unwrap. Okay. something. Yeah, good. Print and panic. T. T is none. Oh, is it gonna troll me? Probably. Classic. T unwrap. I guess we can freaking match. Some T none. Panic. Wrong. Dragon. Okay. Dot map. There you go. What do you want? Option. No. Okay, it's trolling. Okay. So then we just want to print the triangle. I am the triangle. Print the triangle. Do it, son. Frick. Do it, son. The triangle. Yeah, there it is. Good job. Nice one. Proud of you. Print the triangle. Just say that. While expanding this triangle. Go for it. Okay. And it wants me to do some doodly do. Type mismatch. Function option, function triangle. Triangle, new. What? T is the option. Option never. What is this? What does that mean? Is it just trolling me? Am I getting trolled here? Wrapping the function in a closure. Huh? Fin wants destruct. Is that like, am I experiencing some like closure crap? T. What? Wait, why does it want option out here? Are you kidding? Triangle. Hello. Hello. Type mismatch. Is this just a troll and it'll compile fine? No. Okay. Shh. Type mismatch in closure arguments. Expected triangle. Found option. No. I literally changed the function arguments to return option. Are you dumb? Map. Oh. Okay, I got it. Okay. Okay, there we go. Please let me just live peacefully. Okay. Now we can see Which triangle died? All right, murder the triangle. Scene of the crime. Isn't it nice to be able to watch the crime happen again and again while I try to find out how I did it? How did he do it? Go on. Okay, so triangle. You know it. Let's go, buddy. Problematic new triangle. Expanding old triangle. Zoink. Okay. Zoink. Okay. Grab it. Dab it. Okay, so this is the new triangle. Let's just do old triangle only and see where that is. Okay, so the old triangle is here, and the new triangle's over here. So, I mean, that explains what's going on. So it tried to push this triangle up, and it got this point? Okay. So one of my many hunches was correct then? That should be impossible. Because that would mean that this is not convex. But then the epsilon should fix it. What's the delta here? Help. Give me that epsilon crap. What's up? Yeah, this thing. Except not piece of crap. We're done. You're done. Okay, printing. Okay, do it. So potentially if I reinvent the wheel one last time, it'll be good. Okay, so 155 E1 E30 E31. So this number is bigger than that number, but it's trying to find a number when it's smaller on the left-hand side, which should be impossible because it's a convex surface. So we have somehow gotten non-convex points out of a convex surface. So this line here is a dip between these two vertices, which is supposed to be impossible. And that, my friends, is what's going on. That's how the algorithm breaks. My cheek hurts from when I bit it. So the epsilon kind of fixed it. But then it was still broken anyways. Let's chuck in the epsilon here. Give me that. Oh. Go for it. Get it done. Alright, so does this this isn't. Yeah. When I have the epsilon, it doesn't die instantly. It dies later. So let's bear with the spam until it dies, and then I'll be pleased. Okay, spammy, dead. Okay, so we run expand. This is the initial simplex. We add a new vertex. It's not juiced. We add a new vertex. It's not juiced. We add a new vertex. It's not juiced. And then suddenly the distance is negative. And it would seem that we have the exact same situation where it goes back on itself. It retraces a vertex that has already been scouted by the farthest vertex finder. And that's when it fails. And this one is way different. This is way bigger than that, and it'll never be less. No, that'd be nice, wouldn't it? Table. Well, let's do some printing. Let's make a little animation thingy. No. Get going. Next. Yes, sir. 16. 26. This didn't work. 4 to 16. So then we have subset here. Point. All right. So what I want to see is all the points. Do you think it can handle that? I don't know. Point is it? Can you say point if you have more than one point? Cool. That's cool. Okay, go for it, bud. Hell yeah, brother. Isn't that cool? Oh my god, bro. Okay, while expanding this triangle. This triangle. Oh my god. No way. Let me see the triangle. What? So it added a point that was the same point, and it didn't go well. Surprise. Oh, is this just a... No. It's a convex mesh. It doesn't happen. Like, if there'd be so many problems if it wasn't a convex mesh, but like that's why I'm doing physics with convex meshes, because it's very nice for making algorithms. Freaking same thing happens every time. Oh. Okay. Alright. This one. So it tries to add that point again. Is this point in the corner here? That's the last step. Is it tries to add that same point again? No, I'm wrong. One. It's that one. Yeah, you can see it actually. If you look very carefully, you can see it get solider. Yeah, it gets darker right there. I was wrong. Okay. Triangle. Whatever. Let's just smack it in there. Triangle. Here we go. That is very difficult to read. Huh? What? How did it get that triangle? What? Triangle there. All right. Very, very transparent triangle, please. Is that possible? It just displayed. Okay. Okay, I think I understand. So it's expanding this triangle right now. But not that one. So like there's two triangles on that surface. And adding a vertex over here shoof makes that. Okay, well there's a failure case. Okay, so it doesn't happen in 2D. Cool. Okay, that is jumping and screaming. Finally. Finally, I have a jumping and screaming failure case. Oh my god. Could not for the life of me think of this. And like, maybe it's kind of obvious why. So then what should I do? So Trey's algorithm had it going recursively. Okay. Yeah, I see the problem. I see the problem. I see why it like ends up with this last point as the issue as well. Everything makes sense. Finally, 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 everything makes sense. Oops. Shh. Uh. Oh. I'm gonna send this to Trey, please. Oh. We got him. I'm gonna need to think about this. I thought it was impossible. It is clearly not impossible. Yeah, I'm thinking just freak at the edges, basically. If when you introduce the new triangle triple, if there's a convexity, it'll be there. And all you need to do is like uh uh vertex swap. So how do you like say this? Okay, frick. Okay, frick. It's 3D. It's hard. If I was in VR, I could like show it, but um Okay, imagine you have there we go. I can use my hands like this. So imagine my thumb forms a triangle like this. And I have two triangles. Um, so what ends up happening is you have a concavity within the convex shape, which uh, breaks the assumptions of the algorithm. So all you need to do is switch it from a concavity like this between to like make a ridge along there. So it becomes two triangles like that. It's not the most. Okay, I mean, I guess there's four vertices here. 1, 2, 3, and then 4. There's 2 on my thumbs and 2 behind and in front here. Imagine that these are two triangles, and the 4 points, the convex hull of the 4 points forms a tetrahedron. And a tetrahedron is formed of 4 triangles. You just swap the triangles. So you start with these two triangles, and you switch to the other 2 triangles. I believe it would need to be recursive or something, somehow, some way, sort of, maybe. I believe, kind of. I think. Yeah, you're really just like changing which edge the triangles are joined by. It's recursive. I said recursive. Yeah. I wonder if this whole thing can be done recursively. You can stay stacky. You don't need a dynamic memory. It's not that bad. Oh my god. Okay, well, cool. I did not imagine my algorithm breaking like this. Gabagoo, man. Gabagoo. Crikey. Oh, thanks, YouTube. Yeah, just freeze it. Nice one. Good. Nice. Well, I don't have a solution. But I have a problem. Previously, I had nothing. It just didn't work and I didn't know why. Now it doesn't work and I do know why. And I have a nice graphic as well. This is what I mean by like, if I can just see it, I can tell what's wrong. And yeah, don't underestimate the power of visualizing. Golly. I naively I want to like have a little stack and like sweep the triangles, but like I don't know if I can prove that that works. Does it no, yeah, no. Is there an unlimited number of concavities that you can introduce? Yeah, there is. Okay, well, no, I just designed an algorithm actually. Okay, well, so you need dynamic memory. Well, you could use recursion. The original algorithm was using recursion. Oh, it's a swap. You change it from bending this way to bending that way, but like connectivity graph. Change the connectivity graph. You have you have 4 vertices representing 2 triangles, and you swap the connectivity graph. If Okay, yeah, no, you just have a little stack. Let me write it down. Um, check the new triangles to make the neighbors of the new triangles to make sure concavity they have not introduced a concavity. So it'd be like mutt friggin' vec, goddamn. To check. What do I want? Like a vec deck or something? Ugh. Crikey. So it'll be exactly these three goobs right here. Oh, help. Okay, so that's where the machinery comes from. So then the winding order, it only chooses ones with a bad winding order in the original algorithm. Yeah, I do not have the topology of the triangle list. The convex hull. Well, that explains all the hashing. Crikey. You know what? I could. It's like guaranteed to be like flush triangles. Well, I don't know that for sure. Yeah, no, it's not. Um, so actually, you have to replace all the triangles that the new point is above. So you use the triangle. You use the triangle to pick which point to add to the convex hull. But then any triangles that are below the new point are deleted. There's multiple ways to solve this. What would be so like? I need one triangle per vertex pair around the border of the triangles being replaced. I need to figure out what is it called, the perimeter, the cross section, the silhouette kind of. I don't have any topology information here. But I do have a new algorithm. That's nice. Okay, this is stupid. Don't do this. Um, okay, well, I have figured it out. I figured it out. Get out of here. All right, so okay, I mean, blah blah blah. Find the closest face. Very good. If there's a vertex on the surface of the mesh above the triangle, to delete. So okay. It has to be that triangle, right? Yeah. So if it's above that triangle, then we find it could be above any other triangle as well, and we have to delete those triangles, and like whoosh, make a cone around the silhouette. Crazy. That's so crazy. Okay, so nine. Vertex on the surface. Delete the triangle. Create 3 new triangles. That is so not right. Um. Find the farthest vertex in the direction of the triangle normal. If the vertex is above the triangle, find all triangles where that is the case, for which that is the case, and delete them. Vertex strip, create a fan, a triangle fan around the silhouette, the whole. With the new vertex as the center point for each vertex pair around the whole left behind by the deleted triangles. Center point for each vertex pair around a hole left behind by the deleted triangles. Okay, good algorithm. But how do you get the topology? How do you know that it forms perimeter of the whole left? Indeed, sir. May I take your hat, sir? So we found the next point, and then if it's below, we're done. You don't need to check any other triangles. Oh my god. And then we I wonder if I can do some kind of like vertex strip, triangle strip rather. And you can always form like a triangle strip, and that can inform the winding order or something, and I can like it's too complicated. Let's see. How do I know which triangles are adjacent? Well, yeah, without using a bunch of dynamic memory. within the constraints. Only one dynamic memory per algorithm. You cannot use more than one dynamic memory per algorithm, or you die. Ay, ay, ay. Find all triangles. It's not true. It's not true. Wait. If you have a new vertex. No, we are expanding the convex hull. Triangle remove. God, is there some kind of like fancy? No, we need dynamic memory. Frick, now I'm freaking building a whole ass mesh. It went from like, oh, there's triangles on a binary heap to like, oh yeah, dude, make a convex hull. Crap. So like you might be wondering, like, why not check the faces of the mesh? Wouldn't that be faster? Oh yeah, that'd be way faster. The problem is that the mesh is a Minkowski sum of two meshes. We don't know what it looks like because it hasn't been calculated yet. So that I could just calculate the full Minkowski sum, but like the whole point is that it's not doing that, and it's procedural, and that you can like use this farthest vert type situation to avoid doing that ever as well. You never need to have a complete picture. Well, I'm very, very glad to have an algorithm. Um, so it replaces this part. Um, uh, new algorithm plan, baby. Momoko Kikuchi. What's her name? That's probably not her name. The song is called Mystical Composer. Okay. Um, yeah, Panic, I guess. Unimplemented. Bop. It are all triangles. You it only really needs to spread to the neighbors. The whole is contiguous. Well done. Ugh. Okay. Mm. You know, we are in there with dynamic memory. I'm gonna write down some singies. Use edge triangle. What? Crawl, traverse, triangle connectivity graph. Since the whole will be contiguous. Yeah. Yeah. Now you're back to like a stacky wavefront type situation deal. Whole. Good. Well, I'm very pleased. Yeah, boy. Why is this dude using quaternions in a buffer? That's progress. Okay, well now I understand what the machinery was for. So it was doing a recursive edge traversal. So it had a connectivity graph, but it's a oriented connectivity graph, which would work. But then like I still don't get how it could possibly have the sorted vertices and stuff. Yeah, it just whack. It doesn't write both. I'm using a hash map for the connectivity graph. Everything is a hash map in Lua. Hash maps are pretty good. Pretty widely applicable. I do not see a simple solution other than having more dynamic memory. It's not the worst, because like it's a kind of a edgy case. I'm gonna need there's so much cleanup that needs to happen, especially with this. Yeah, so like if you want closest fev, it can return you a gadget to do further calculations. Is intersecting. Does that ever freaking happen? I don't know. One good way to find out. Blessed print. Blessed are the print statements. Nice seg fault. Not implemented. True. So true. Just absolutely true. The truest. We don't care. Okay. 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 Just shh. How does session get involved there? Alright. Did it happen? Print it. It doesn't happen. What if I go over to the... God, this is smooth. Unreal. The Zorgazelle of different triangles. Triangle hell. Cool. Right here. Yeah. All the triangles. More triangles. Oh, it happens! No way! So it knows the exact result without needing to run the expand algorithm, but it's intersecting. That's so weird. Very curious. You know, feels so good to play. Imagine if you didn't fall through the ground. That would be nutty. I believe it's only taken 2 years to fix all the physics bugs, and I'm not done yet. I guess there was no. It's one issue. I mistook it for 2 issues. Not with the physics bugs. There's 5 physics bugs that cause you to fall to the floor. But I am on my way to fixing the biggest one. It'll probably take about a month, if I had to guess. And I have just started. I've been working on this for like 3 days. This is looking like a Herculean task, just like all the other ones. But I'm here for it. That's why I'm writing my own game engine, is because it's fun. Yeah. Oh. Damn. Damn. Well, that's about all the effort I have for today. I will ponder the algorithm's needs and come back tomorrow fresh in mind and body. Excellent. Oh my god, that it was infuriating to like watch it fail reliably and not be able to think of any failure cases. I've always considered myself an expert at considering the failure cases for algorithms. But it was just a bit too spatial with a bit too many like things that can happen. I just couldn't imagine something that could happen like this. That is the failure case. Add 1 triangle, add 2 triangles. I only had a way to add 1 triangle. Or to like expand 1 triangle. So you see how there's a triangle here? That doesn't go away. It's this, that one face is made up of 1 and then 2 triangles. And so when it goes to add this new point, it would only expand one of those triangles and you would end up with a in the middle of it. It would be spiky, not convex. That's the problem. That's what I couldn't figure it out. That's what I couldn't figure out. But now I know. So now I can consider it, ponder it, and invent an algorithm that does not suffer from the same issues. And then the expansion should be complete, and we'll have an exact result of the closest point between 2 convex meshes. And then I can determine the exact distance and the contact point and make it so you don't fall through the ground when you walk from one flush surface onto another flush surface. Pretty big deal. Okay. How is nulls cheating? It's using external, it's like using external software to, it's inhuman input. No human could ever produce consistent 0 time switching between A and D, or 1 frame. So you are I don't know, juicing steroids type thing. Like if it was built in the game, then it's fair. But it's not built into the game. And like, I don't know, I feel like people should worry about it. Like there's no point in having sync gauges and stuff if you just know all the time. You just mash your keys, smash both of them at the same time, and then it just isn't a problem. It's up for debate. Okay. Bye.